Alright, let's see what the internet has to offer today. Oh, look, it's one of those top 10 lists. I love top 10 lists. I love it. You name off 10 reasons why something is something. It's great. You know, I love numbered lists where you put the number before the reason of something. Yeah, those things are great. Let's see what this one has to say.
Round planets, and look, they put the sun right in the middle of it. Like that's a planet too. We should be on fire maybe.
Number 10. All the other planets and stars we've ever seen are round, and there's no reason to indicate that the Earth should be any different.
You just saw the number 10 reason. Other planets are round, so automatically the Earth must be round. Now, this is about as stupid as it gets.
Well, this is awkward. Mr. Thrive and Survive, you're right. Oh, that left a terrible taste in my mouth. Oh. In all seriousness, though, you are actually correct about how looking at all the other planets around us and then assuming that ours is round is actually fallacious. It is like saying that all swans are white just because we've only ever seen white swans. It is actually incorrect. To give a little bit of credit to the person who made the video, I think what they meant to say is that it gives us a clue to the shape of our planet. The other planets should give us a clue to how our planet should be shaped. It does not necessarily prove or demonstrate that our planet has to be round. We actually have other reasons for why our planet has to be round, considering the laws of physics and many other things that we'll talk about later. Now, if you would have stopped right there, we could have had a nice little conversation where I actually said you were right and we moved on with life, but you didn't shut up there, and so now I get to call you an idiot.
Round planets, and look, they put the sun right in the middle of it. Like that's a planet too. We should be on fire maybe as the Earth. So using that is just plain stupid.
Not as stupid as the fact that you don't know how to read. So when you make a list of things and you number them, you usually put the number and then a period afterwards. A period denotes the fact that the sentence has ended, so 10 is actually separate from whatever comes next. What you have stupidly done here is you have stuck the words together. 10 other planets. Do you not know how to fucking read? It doesn't say 10 other planets, it says 10 other planets all around. This is why you should have just shut up earlier and not look like a fucking moron.
Number 9. Time zones. Day and night happen at different times at different places on Earth. In fact, it's always day somewhere and night somewhere else.
You have to be seriously kidding me. It is always light someplace and always dark someplace else. This is a proof of a round Earth? I guess there's no imagination left with the people of the world. I guess that's pretty much true. They can't imagine. How would it be light and dark without an Earth spinning? Well, here's the answer right here, isn't it? Right in front of your face. This little animated GIF shows you how the sun and moon rotate around a stationary Earth. Isn't it always light someplace and dark someplace else?
Alright, Mr. Thrive and Survive. It actually has nothing to do with your imagination. I mean, I can imagine myself being a Pokemon trainer, but that does not mean that Professor Oak is about to call me up and give me my first starter Pokemon. What matters isn't the shit that you can come up with. What matters is if the shit that you can come up with actually holds up when it is tested. Thankfully, you actually gave us something to test. I'm really glad you gave me a model to work with. That's actually pretty awesome. It means there's actually something here that I can test and sort of take a look at and see how well it matches up with what we see in reality. Now, I do want to point out something about your little GIF here, and that's that I think that you use an animated GIF for a very specific reason. An animated GIF is constantly moving. There's no real way to stop it or slow it down, or even interact with it in any way to see where the position of the sun is and where the light lands at any given point. And I think that you use this GIF because of those limitations, which makes it a lot harder to test. Because at first glance, this actually seems like a reasonable way to see the sun go across the sky. But it's actually when we slow it down and stop it and actually see where the sunlight is and where the sun is that your whole little model here starts to break down. Now, I'm going to take your little GIF of the sun rotating around the earth and we'll stop it right around here. Now, if I stop it here, you'll notice that on your GIF, according to what you say should happen, if the very tip of Africa is sort of starting to have sunrise, then the sun should cover all of Russia and China and India and the Middle East, leaving Australia, North America, actually all the Americas in complete darkness. It's nighttime in those places. So remember, Americas, Australia, Hawaii, nighttime. Let's look at how well that matches up with observable reality. What we have here is a day and night world map. It shows us what parts of the world are in daylight and what parts of the world are in nighttime. This is based off of what we actually see in observable reality. So if you were, say, somewhere in Spain, you could call up someone in Australia and find out that while in Spain it is starting to become daylight, in Australia it should be starting to get closer to the evening. This we can actually test out today. Now, the one thing that you might notice right away from this map compared to the GIF that you gave me is that they don't match up. Now remember, in your GIF, what we said was that if it is starting to become daylight in Africa, Australia and the Americas should be in complete darkness. And that doesn't actually match with reality. As you can see, when daylight is first starting to hit Africa, there's still daylight in Australia. Your model of reality doesn't match up with observable reality. Your hypothesis that the sun rotates around the earth doesn't actually give us the same kind of effect that we actually observe in reality. Now, I'm going to be very kind to you, Mr. Thrive and Survive, and I'm going to take into account the fact that many flat Earth models have the sun getting closer to the north during part of the year and then closer to the south during another part of the year. And we are going to set our day and night world map to September, which, if I remember right, in an earlier video, I talked about how in September, according to a lot of flat Earth models, the sun should be going around about the equator. And I know you don't believe in the equator, but around where the equator should be. We're going to change our map to September instead of October, which it is now, and then we'll see what we get then. Once again, the sun is starting at about Africa. It's getting to be morning, and once again, Australia is in full out evening. It is not in complete darkness like the model that you gave me says it should be. So we've tested out the model that you have given us, and most honest people, after having their models tested and been disproven, would throw them out. But I get the feeling that you're very attached to this model regardless of whether it works or not. So you're going to stay attached to it, even though your model says silly things like if it's daylight in Africa, it should be pitch black in Australia, which is demonstrably wrong. So these kinds of silliness are not reconcilable with reality.
Number 8. The Coriolis effect means freely moving things like cannonballs or hurricane winds are deflected to the right, but only if you're north of the equator. If you're south of the equator, they're deflected left.
Maybe that video should be renamed to the top 10 most ridiculous things that brain-dead people would think of to try to prove a spinning globe. Why in the earth would anything south of the equator spin one direction and north of the equator spin another direction when the entire earth is moving in one direction? That makes absolutely no sense whatsoever.
Just because something doesn't make sense to you doesn't make that something wrong or untrue. For example, mechanical engineering makes absolutely no goddamn sense to me at all. Every time I see someone pop open a saw or a drill and they show me all the mechanical stuff inside, my brain just shuts off and it makes no sense. Now that doesn't mean that I can therefore say, oh, it doesn't make sense, therefore little electric pixies do all the work because I don't understand how this one thing works. That is your fault. No one else's fault, but your fault. So you were actually given an example of this with the merry-go-round in the video that you were criticizing. This isn't anything that's too new or too misunderstood. We understand the Coriolis effect really well. So I'm not actually going to try to explain to you how the Coriolis effect works. Mostly because I don't think you'd listen. There are plenty of videos out there really explaining it to you. There are plenty of models out there explaining it to you. And even the video that you yourself criticize gives you an example of the Coriolis effect in front of your very eyes. And yet you still come out with this, I don't understand how this works. So I think I'd be wasting my time on you trying to explain the Coriolis effect. So instead I'm going to direct you to some other people who have explained it rather well, and I think will do a much better job than I could do. However, I do actually want to explore the model that you create in order to explain the observation of hurricanes and storms spinning one direction in the northern hemisphere and a different direction in the southern hemisphere. That is far, far more interesting than explaining the Coriolis effect.
Well, if you look at the video link I showed, you will see that there was a perfectly good explanation for it. I would be doing an update video on this, which shows it even more perfectly. The sun and water, as you will see in the video, produce magnetic effects to where anything to the north of the sun, as it moves right to left across a stationary Earth, pushes everything away from it, ahead of it, which would cause it to curve to the right for high pressure systems in the north, and it would cause it to push away the opposite way south of the location of the sun. Can you see that?
You've created a very interesting model to explain the Coriolis effect, and it has some very interesting implications. One of the implications that sort of happens because of the model that you created is that you've made the model time dependent. Now, the Coriolis effect now depends on the position of the sun above the Earth. So it's now dependent on what time of day it is, which means that if the sun is, say, over by Australia or China in the Middle East, it shouldn't be having any effect on anything that's going on in the Americas. And the same thing would be true the other way. If the sun was over near the Americas, it really shouldn't have any effect on anything going on, say, in Egypt or Africa. Now, I don't really know the range of your sun's magnetic force. You don't actually give it to us. I'm pretty sure you do that because if you actually gave us a amount for the strength or the range of your magnetic field for your sun, we would be able to test it, and you don't really want us to actually test it. Now what you have here is a day-night map of May 8th of 2015 at 3 o'clock UTC. What's so interesting about this particular day and time is that at this time a storm called Storm Ann decided to form itself around Florida. Now, again, according to your model that the sun should be the force that creates the Coriolis effect, I am particularly curious as to how the Coriolis effects or the magnetic force of your sun is able to reach from its position near Japan all the way to Florida. Of course, you don't actually give me the range, like I've said before, so I don't actually know if it should be able to reach that far or not. But again, that is one of the failings of your model, that your model doesn't entirely explain everything. It fails to explain things like storms at night, why they are affected by the Coriolis effect, if it is in fact the sun that is creating that effect and not the motion of the Earth. Now here's another interesting effect of your explanation for the Coriolis effect. If we imagine the sun moving across the sky from east to west like you say it does, and there's a storm that is to the east of the sun, then it should hit the magnetic field and be pushed away, making it have that right-hand curve that we see in storms and hurricanes in the north hemisphere. And then the same thing would be true if something were to be just south of your sun and being hit by the magnetic field. It should turn away from it, giving it that counterclockwise turn that we see in the southern hemisphere. The problem is what happens when a storm is to the west of your sun. Now, if you have a storm on the west of the sun and it gets hit by the magnetic field, there's no reason for it to curve around the sun in a clockwise fashion. It should be pushed away. So it should actually be curving to the left in a counterclockwise on the north. And then if the storm is to the south, it should do it on a clockwise manner in the south. So what we should see is that we should see storms to the east of the sun follow what we see today, which is that in the northern hemisphere they turn clockwise. In the southern hemisphere, they're doing counterclockwise. But storms that are to the west of the sun should turn the other way. So on the south, they should turn counterclockwise, or clockwise on the south, and counterclockwise in the north. And this is not what we observe at all. What we observe is that there is a clear line between the northern and southern hemisphere and the way storms sort of turn in those areas, but has nothing to do on whether the sun is east or west of it. Now, you really do have a lot of shit for me to go through, so I'm just going to cut it off at these 3 proofs, and I'll talk about the other 3 in the next part.